Hello everyone, you are welcome to today's class. Our topic today is arrangement of resistors. Radio and television receivers contain a large number of resistors in their electric circuit. A resistor is an electronic component that controls or limits the flow of electric current. A resistor is identified in a circuit diagram by either of this symbol: fixed resistor, variable resistor, referred to as a rheostat. Resistors are arranged in two primary ways: in series and in parallel. A third type, called a mixed circuit, includes both series and parallel arrangement. The arrangement significantly affects the total resistance of the circuit. Resistors in series. A number of resistors R1, R2, R3 in ohms are said to be connected in series if they are connected end-to-end consecutively. So the current must pass through each one sequentially. That is, the same current I flows through each resistor. The potential difference across the resistors are V1, V2, and V3 respectively. The total resistance is the sum of the individual resistance. R total is equal to R1 plus R2 plus R3 plus Rn. Resistors in parallel. Resistors are said to be in parallel when they are placed side by side and their corresponding ends joined together as shown. In this case, the same potential difference V exists across each of the resistors, but they will share the main current I in the circuit and must be equal to the sum of the three currents I1, I2, and I3 with individual resistors as shown. The total resistance. The inverse of the total resistance is the sum of the inverse of the individual resistance. 1 all over R total is equal to 1 all over R1 plus 1 all over R2 plus 1 all over R3 plus 1 all over Rn. Mixed arrangement. This circuit combines both series and parallel connection. The total resistance is found by first calculating the equivalent resistors for each individual series and parallel section and then combine both results. Example: find the equivalent resistance between A and B in the diagram above. Looking at the diagram, R2 and R3 are in series. So R is equal to R2 plus R3. Substituting, R is equal to 8 plus 4. R is equal to 12 ohm. This 12 ohm is in parallel with R4, which is also 12 ohm. For resistors in parallel, 1 all over R is equal to 1 all over R1 plus 1 all over R2. Substituting, we have 1 all over 12 plus 1 all over 12. The LCM is 12. 12 going to 12, 1. 12 going to 12, 1. 1 plus 1 will give us 2. 1 all over R is equal to 2 over 12. Therefore, R is equal to 12 over 2. R is equal to 6 ohm. R1 is in series with this whole arrangement. Therefore, R is equal to 6 plus 6, which is equal to 12 ohm. Find the current IT, I1, and I2. Determine the potential difference across each resistor. Total current from A, IT, is equal to V all over RAB. RAB is the resistance between point A and B. IT is equal to 12 over 12. IT is equal to 1.0 ampere. 1.0 ampere flows through R1. At this junction, the current splits equally since the two parallel branches are both 12 ohm. I1 will flow down through R2 and R3. Resistors in series. I1 therefore is equal to 0.5 ampere. I2 will flow through R4. I2 is equal to 0.5 ampere. Current in the individual resistors. R1 is equal to 0.1 ampere. R2 is equal to 0.5 ampere. R3 is equal to 0.5 ampere. R4 is equal to 0.5 ampere. Voltage drop. From V is equal to IR, for R1, V1 is equal to I1 times R1. V1 is equal to 1 times 6. V1 is equal to 6 volts. Remember that the whole of this arrangement is in series with R1. The new arrangement will look like this. For resistors in series, they have different potential difference. So if the total potential difference is 12 volts and the potential difference for R1 is 6 volts, then the potential difference for the other resistor combined will be 6 volts, which is V1 plus V2 is equal to V total. 6 plus V2 is equal to 12. V2 is equal to 12 minus 6. V2 is equal to 6 volts. That means the 6 volts is acting across R4 and across R2 and R3 combined. The potential difference across R2, which is VR2, is equal to I2 times R2. VR2 is equal to 0.5 times 8. R2 is equal to 4 volts. The potential difference across R3, VR3 is equal to I3 times R3. VR3 is equal to 0.5 times 4. VR3 is equal to 2 volts. If you add V2 and V3 together, you will get 6 volts, just to check if we are correct. share your thoughts with me. And if you have any question, you can drop them at the comment section below and I will respond to them as soon as possible. See you in the next class.